Guys, we're going to move on in this video, and we're going to talk about another instrument. But we're going to keep it in the chromatography world. So we've talked about high-performance liquid chromatography, right, HPLC. We've talked about gas chromatography, which is GC. And in this video, we're going to talk about ion chromatography. So ion chromatography, known as IC. All right, so first, we've got to talk about what this word ion means. And if you've taken a general chemistry course, or maybe if you're taking the 114 course, maybe we've made it up to that point so far. But an ion basically means a charged atom. And there's two different charges. Think of ends of a magnet, right? There could be a positive and there could be a negative one. And it really depends on the atom itself. Some are really mean parents and they will kick their kids out to the curb when they turn 18. Well, they lose the teenager, right? And others will keep the teenager until they probably become 30 years old and they still want to live at home. But in addition to that, they go out and make a friend and they want to bring the friend home too and let them live with their mom and dad. So they gain a resident. They become a landlord. Okay, well, depending on if they lose or if they take in, well, this is where we get a positive and a negative charged atom. What are they losing or what are they taking in? An electron. And electrons are negative. So if they gain an electron, then they become negatively charged. If they lose an electron, well, they become positively charged, because they're either gaining or losing a negative. That's what an electron is. All right, well, we have proper names for each one of these. If it is a positive charge, we call this a cation. The T is positive, so T means positive. And the negative, if they gain an electron, is called an anion, an N in there for negative. So these atoms could be positively charged or these atoms could be negatively charged. A cation or an anion. But notice the word ion is in both of these. Well, ion chromatography will focus on measuring cations or anions. So how does it do it? Well, I'm going to draw a box. Very similar to HPLC. There's some liquids up here at the very top. I'm not going to really talk about those liquids, but just like with HPLC, these are your mobile phases. Without mobile phases, your sample does not go through the machine. Over here to the side, your sample gets sucked up and it gets mixed with the mobile phases. The mobile phase will then push it through what we would call a column and out the other end. And we would have a detector over here that would see everything that comes out. The purpose of the column, just like before, is the separation. It separates all of the cations from each other, or it separates all of the anions from each other. Puts them in groups and sends them out one by one by one. Well, you're probably scratching your head right now, and you're probably saying, well, this looks like an HPLC drawing. Didn't we just do this a couple of videos back? And the answer is, yeah, you did. That's exactly what IC is. IC is a form of high-performance liquid chromatography, but it's just a version of it, meaning that the pressures aren't as high, and this is more specialized. HPLC does a really good job separating organic compounds from each other. But notice the terminology that I used. Organic compounds is typically what gets injected. Well, for IC, it is specialized for ions, not necessarily full-blown organic molecules. So, for instance, aspirin. Well, aspirin would be a great candidate for HPLC. It's not very volatile. They put it in a pill and you swallow it. Aspirin could decompose up at a certain temperature. It's not going to turn into a gas, though, very easily. It's not suitable for GC. It does great in HPLC, but what if I put aspirin into the IC? Well, in a normal IC system, it's probably not going to pick it up because we rely on cations or anions, positive or negatively charged species. Well, what would some of these things be, right? If it can't pick up aspirin, what is it good for? Well, things like fluoride or chloride content or bromide content or nitrate and nitrite contents or sulfate and sulfite contents. Maybe I'm drinking a bottle of wine and I look on the back and it says may contain sulfites or sulfates. What's the big deal in that? You'll learn that in our food chemistry class. But if I wanted to measure those sulfites or sulfates or nitrates or nitrites, maybe in ground up meat, well, I can process those samples and I can run them on the IC system. As far as fluoride goes, fluoride is an additive to your water supply. You drink it. They put it in there so you don't rot your teeth out of your head. Well, they have a limit. It can't go above a certain level. If it goes above a certain level, then they're in violation of EPA regulations. So if I was working for an environmental company or if I was working for maybe CFPUA, this is a number that I would constantly want to keep an eye on. I would constantly monitor the fluoride content in the drinking water samples to make sure they're not over the limit. Well, IC would do a wonderful job for that. That's the purpose in it. Ion chromatography. Okay, well, what about on the positive side? Well, we can measure things like calcium, Ca+2. We can measure things like magnesium, Mg+2, sodium, Na+, lithium, Na+, ammonium, NH4+. All of these are positively charged. Those are cations. Those can be monitored in the IC as well. Well, you're thinking, well, wait a minute now. These are metals. Lithium, sodium, magnesium, calcium. Couldn't we measure these on AA? We just learned about that. And the answer is yeah, you could. No big deal. You could measure the calcium content on an AA instrument, and you can measure calcium content on an IC instrument. Nobody says that only one instrument can do one thing. There's different ways that we can analyze things in the laboratory. I'm just kind of telling you one of the choices that we would have. Well, I can measure calcium a number of different ways. I can bring that into a wet chemistry lab. I can do a titration to measure the calcium content. No equipment required. I can take a probe, like a pH probe, but it's meant for calcium. I can dip that down into the solution and I can measure calcium that way. No one says there's only one way to measure something. There's different possibilities out there. No big deal. That's the wonderful thing about the analytical world. All right, so the ion chromatography system, that's basically what happens here. We call it IC, and it separates positives from negatives. Okay, now, let's say that I am analyzing some wine sample, and one of those components that I would want to know about would be tartaric acid. Tartaric acid is naturally produced from the grape. And depending on when the grapes are picked, they could have different tartaric acid contents. And the type of grape would have different tartaric acid levels as well. And let's say that I measure wine, but I know that maybe acetic acid could get formed as well in that sample. Kind of sour, kind of bitter, vinegary. Well, that's acetic acid. Well, these two, they're organic. And yes, they are organic. We could measure these in HPLC. They are organic molecules. They're not very volatile. They're not suited for GC, but they're great candidates for HPLC. However, tartaric acid and acetic acid, they can also be slightly charged. They're polar molecules, and we can do something to the solution to make them free up, because they're acids, to free up their H pluses. All right? So if they kick off their hydrogen content, which is the definition of an acid, it kicks off hydrogen, what we're left with is a molecule that has a negative charge. Again, that's the definition of an acid. If I can force these acids to kick off a hydrogen, and if I'm remaining with a negative piece at the other end of it, then this negative, by definition, is an anion, and by definition, I should be able to run it on IC, and I can, as long as the conditions of the sample are appropriate. These molecules will be negatively charged, and I can measure them using an ion chromatography system. Okay? So that's the purpose of IC. Very similar to HPLC. The diagram is almost identical. The difference is the column, the separation. It's separating things based on charges. It's not separating things based on polarity like HPLC would do. Okay, so who is our, well, first, before I tell you who our manufacturer is, these IC systems, they're around $35,000 a piece. Again, they're on par to an HPLC system, and we have a total of 3 in our laboratory. We do a lot of things with ion chromatography. 2 were purchased with grant money. The other one was purchased with equipment hearing money. So $35,000 times 3 is what we've invested into the IC system. As far as the columns go, these columns are as much as they are in HPLC. You're looking at $2,500, maybe down to $2,000, $1,500, all the way up to $3,500 for one particular column. That will have to get replaced depending on the usage every 3 to 4 months, maybe, if you're lucky. Okay, we don't use ours as heavily as that, so ours typically last a little bit longer, but that's the investment cost that you're going to have to put into the system. As far as the mobile phases up here at the very top, these mobile phases are typically just buffers, and that basically means they're mainly water, and it's water mixed with a little bit of powder. Typically like sodium carbonate, sodium bicarbonate, maybe a little bit of acetone thrown into the mix to help the separation. So as far as mobile phases go, there's hardly any investment in that at all. It's mainly water with a little bit of powder. And when I say powder, 2 liters of water with maybe 0.3 grams of the powders that I need to make these mobile phases with. Super, super tiny amounts that will last me forever and go a long way. So the cost really is in the columns. The cost is not in the mobile phases with this machine. Unlike HPLC and acetonitrile and methanol, which I would have to purchase, right? Okay, in addition to this, we do have auto samplers for our IC systems. We have 2 auto sampler samples, and these were around $8,500 a piece. So we have 2 auto samplers now, one on each instrument. We have dedicated 1 instrument to cation analysis. We've dedicated 1 to anion analysis, and we've dedicated our 3rd to what we would call organic acids. So that would be something like tartaric acid and acetic acid down here at the very bottom. So we have 2 auto samplers. Each one was about $8,500 a piece. You can do the math, see how much money we've got tied up into the ion chromatography world. The ion chromatography rep basically told us that out of all of the colleges in the entire state, we probably have the most IC systems that's out there. So the company that produces our IC system is called Metrome. And if you just type in Metrome to Google, you're going to see metrome.com. That's going to be their main website. It's probably going to be like a worldwide global website. They are a Swedish-based company that really has operations across the world. But if I click in the products and I come over here to the side, you're going to see, like many of the other instrumentation manufacturers, they do dabble into a little bit of other things. But ion chromatography is really how they got their start and what they're known for. There are other companies that are out there that might be a little more known than Metrome, but Metrome is up and coming. If it's not in a laboratory, it will be in a handful of years. But there's other companies like Dionix that you might see in a working laboratory with ion chromatography. So I'm going to click ion chromatography. and you're going to see basically a picture of an IC system. This is what the things look like. Ours is not this pretty. This has a see-through door. The ones that we have is a solid door in front, not a see-through door. No big deal. Everything else on the insides, though, they're pretty much the same. This is what they're calling the Compact IC Flex. So it's just an updated version. They've changed and tweaked a few little things on the inside, but nothing too major. What we have is basically comparable to this, except ours is not as pretty or fancy looking, but it still does the same job that it needs to do. So just like with all of them, I can click the IC Flex. It will pull up more information about the instrument itself. There's a couple of videos that are associated with it, kind of telling you what it does. Over here to the left-hand side, this is the auto sampler unit that you're seeing connected to this instrument. Notice all of the samples that go up on top. I think that this thing can hold 30-some samples in total. I think 36 if I'm not mistaken, at least. And this auto sampler will suck up sample from your kind of small conical test tubes here, and it will deliver that into the IC system, and it will analyze everything that it needs to analyze here through the front. So it's hooked up to a computer, it's hooked up to software. That makes it work. That's where all the data gets lumped into, and it's your job as an analyst just to go back and print that data off and then process it the way that you need to process it. So it is robust. It's very easy to use, hence contract laboratories and quality control laboratories from all sectors with clearly defined analytical requirements will find the 930 their solution of choice. So ours is not model 930, but it's basically the same as what you're seeing here. It's an older model number, but no big deal. Okay, so there's the Ion chromatography system, and there's the auto sampler that is paired with that system. And again, we have a total of 3 in our laboratory that you will use. The problem here is that Ion chromatography takes forever to run. You're talking about 30 minutes at least on average for a sample to process on the Ion chromatography unit. So when you have maybe even just 8 or 10 samples at 30 minutes apiece, well, you can calculate the number of minutes that it would take to fully process a set of samples that you would have for that day. So that's the problem with IC. Here's a picture of it opened up so you can take a better look about what's on the inside, and maybe just another version of the auto sampler that's over here to the right-hand side. Okay, so that's the story with Ion chromatography. Again, we'll go into details in the instrumentation courses. That's not the purpose of this one, but I'll try to give you an overview with some exterior videos that you might see from Metrum. All right.